Welcome to 158 Concord Ave, Belmont, Mass. You're staring at what used to be a 1920s Colonial, but now it's built for 2015. This high-performance green home stands alone in today's marketplace. At 2,700 square feet, this house operates at a high efficiency and it has a lot of comfortability for those who are going to be living here. It is the most energy efficient home I've seen in a long time. I'm here today at 158 Concord Ave in Belmont. I'm with Brian Butler.
And what we're doing here is a deep energy retrofit of an existing Colonial. We're taking this house, built in about the 1930s, kicking and screaming into the 21st century. We're going to go something pretty close to a net zero energy house. So what we're looking at here is the original wall, the original 2x4 stud wall, and we've added a staggered stud, double stud wall to the interior of the structure, also 2x4s, for an effective cavity depth of 10 inches. And that'll give us an opportunity for a lot of insulation, and we'll do our air sealing detail in here with what we call a flash coat of closed cell foam sprayed to about 2 inches of depth. So the combined R value of the closed cell foam and the dense packed cellulose would be about R40. So when we're getting the house this tight, we really have to start thinking about air quality. In a deep energy retrofit, you're actually going to have better air quality than you would in any conventional house, because we're actually providing outside air, fresh air, where we take it from a point furthest away from any known air pollution sources, the road, the driveway where you might have an engine running. So we're bringing in fresh air, we're exhausting stale air, and we're running through a heat exchanger where we actually capture that waste energy and raise the incoming air temperature, if it's wintertime, to something pretty close to the outgoing ambient temperature.
And if those have chemical sensitivities, this could be something that actually helps create an environment that they can breathe in.
That's honestly where these houses started to become popularized. It was, energy was kind of a nice byproduct of that, but really what's driving this was people with allergies and high sensitivity. The super insulated homes they're comfortable, but they're also extremely good air quality.
Wow, look at this place, Brian. I can't believe how great it looks. Brian, tell me a little bit about this place, compared to other projects you've done. What makes this super green?
The quick background is the clients took advantage of the National Grid Deep Energy Retrofit pilot, which is actually a program now, it's not a pilot anymore. But so they took advantage of the significant incentive to do the super insulation, the high indoor air quality, and the super high efficient mechanical systems that make up the building components.
So this is a triple glazed window.
Triple glazed window. It's a tilt turn.
The thickness of this window is, looks thicker than an average exterior door. I mean, look at this thing here.
Oh, this is a tank, man.
Yeah.
These are built like a tank. The heat that we do make, we want to make sure we retain and don't lose to radiant losses with cold glass surfaces.
What's the R value of something like this?
This is probably about an R7, which relative to an American window, you're probably talking more like an R3. In the window universe, that's an incredible quantum leap.
What else we have to see?
Let's take it to the mechanical room.
Yeah, check out that engine room, right? So here we are, engine room.
Hey.
I feel like I'm in Star Trek over here. So tell me a little bit about this system, where it comes from, and what does it do exactly?
So this is actually a dual function boiler and hot water system. Makes it domestic hot water and also heat. This is one of the highest efficiency boilers you can get. I believe the efficiency is up around 98%, so it's a very high performance piece of equipment.
So Brian, here we are outside. We're looking at what looks to be a heat pump, right?
Yep, exactly. So this is our one departure from all the German technology that got incorporated into the house. This is actually a Japanese system, but it's one of the highest efficiency grades of heat pump you can install. This will actually make heat down to sub-freezing temperatures. You'll go down as low as 5 to even 0 degrees Fahrenheit, and this is still making heat for you.
So even though it's -5 degrees or even better than that, this is still going to produce heat inside?
Correct.
Wow. So how much over code do you think this is compared to something of equal counterpart?
Over code, more than double. Over the national average, triple.
Triple.
especially in this part of the country, the Northeast. You know, we have an older housing stock. Energy ratings on homes in this area tend to be about 50% worse than code. So we've got a house now that's about 100% better than that, and about 50% better than code. It really is future-proofing. You know, to go and take maybe a little bit away from other parts of your budget, to actually put it into the envelope is going to be huge in terms of the housekeeping its value over the long term. You know, as more and more homes get built to a stricter energy code standard, these older homes are going to fall behind in their desirability. So, but not this house.
Right. This place definitely looks like it's here to stay for a while.